Hello guys, welcome back. In the previous videos, we have discussed quite a lot of things, and in the last video we discussed about OS and basic Unix commands. Now we are slowly heading towards the C programming, and only the last topic remains before actually starting programming in C. And the last topic is algorithms and pseudocode and flowcharts. So let us first understand what algorithms and pseudocode means. So algorithm is a step-by-step procedure. You must already be knowing about it that in order to perform any operation, be it making a cup of tea or writing some piece of code, we have to follow a process, and it is the algorithm that we are speaking about. Algorithm is a step-by-step guideline. It is actually a process or a flow in which we have to approach our problem. So the definition of algorithm says that algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output, and it is independent of the underlying programming language. Yes. So first of all, I've already said that algorithm is a step-by-step procedure because we cannot solve any problem in one go. We need to approach it slowly and gradually by solving one step at a time. Next, an algorithm defines a set of instructions which are to be executed in a certain order. Obviously, in order to solve a problem, you cannot just take any step in any haphazard manner. You have to consider one particular order and you need to proceed in that order itself. And only then shall you get some relevant output. Now, ultimate goal of any algorithm or any code is to get to an output. So that is what it is saying. Now, an algorithm is independent of the underlying programming language. Yes, because the general approach to solve any problem always remains fixed. It is just the language that is completely dependent upon the programmer, uh, that which language will he prefer to use. Someone might be very good at C++ or C, and some other person might be good at Java or Python. So it is completely up to the programmer which language he uses. But in general, the algorithm remains the same. For example, consider a situation when we want to make a cup of tea. If you want to make a cup of tea, you can use any type of stove. It can be a induction stove or it can be a normal conventional stove that we use, the LPG one. But the process remains the same. You can use any kind of tea leaves, but ultimate output will be the same. You will get tea. Only the taste may vary if you change the tea leaves. That is all. So even an algorithm is analogous to that case. Now let us discuss about the properties or characteristics of an algorithm. Now, an algorithm has five main characteristics, and the most important of them is finiteness. This is the first property. Now, finiteness means that whenever you write any algorithm or any code, you must head towards the output, because it is not at all worth it if you write any algorithm which continues till the end of the time. That becomes an infinite loop which will never terminate. So that is not our goal. Our goal is to solve a problem. So by every step that we take, we should approach the problem. We should get closer to the problem. So that is what the first point means. The second point is definiteness. Every step in an algorithm must be well defined, and the actions to be performed must be well specified with unambiguous outputs. Yes, obviously, if you write, say suppose, if you have an expression and within that expression you have somewhere written, say suppose 5 by 0 or 5 divided by 0, that will obviously provide some erroneous output because 5 divided by 0 is an undefined quantity. So that is an ambiguity in the code. So that is what it says. Whatever you write must be very clear and concise. It must not produce any unambiguous it should not produce any ambiguous outputs. The next thing is input and then the output. So every algorithm must take in some input. Otherwise, it makes no sense to write any algorithm, because an algorithm after all has to work on some input that the user is providing. So that is what this third point means. And the fourth point is an algorithm is written to solve a problem. Now, if you're solving a problem, then corresponding to the input that the user provides, the user must receive some output. The output may be one or more, but it must have some output. And lastly, effectiveness. All operations must be designed to solve a particular problem in finite number of steps. Yes, an algorithm should be effective. If you want to make a cup of tea and you're writing an algorithm on how to prepare some curry, then it makes no sense because your problem is not solved. The problem of preparing tea is not solved. Instead, you have written the algorithm to prepare curry. So that is not effective algorithm. Now, there's a slight difference between algorithms and pseudocode. People generally confuse between algorithm and pseudocode. They confuse it a lot. But algorithm is actually a textual set of instructions. That means we do not follow any conventions, any programming conventions or anything like that. It is just in form of normal lines which are written pointwise. And the statements that we write in those lines are actually our approach. It is our approach which is written in English language, in literature kind of language, about how we approach a problem. And on the other hand, pseudocode is similar to your original source code, but the only difference is that pseudocode does not follow any syntax. It is let's see what the definition says. Pseudocode is a description of a problem in a human readable form than machine readable form. Yes, pseudocode is actually giving you an overview of how you want to write your code. It is not your code that you want to compile. It is just an overview of your code. It is just an outline on the basis of which you have to write your ultimate code. It is not bound to a syntax of coding and follows structure similar to computer programming. Conventional programming. Now we discuss about flowchart. Well, over here, this entire term, that is flowchart, it can be divided into two parts. The first part is flow and the second part is chart. So basically, it is a chart that depicts the flow. Now, let us see what the definition says. Flowchart is nothing but a graphical alternative of pseudocode. Yes. In pseudocode, everything is written in textual form, and in flowchart, you represent the same thing but in a graphical manner using certain symbols, shapes, and some arrows or lines. A flowchart depicts the flow of the program structure using some shapes which have a specific meaning. Yes, every shape that you use in flowchart has a specific meaning. And flowcharts are very necessary when you want to design the overview of a big program or a big piece of software that you want to write. It is a very essential part. A flowchart is a visual representation of the sequence of steps and decisions needed to perform a process. Each step in the sequence is noted within a diagram shape. Yes, in this part what it's written is, first of all, you denote the sequence of steps that you want to follow using some shapes. And inside that shape inside that shape you write what you actually want to do in that particular step. Steps are linked by connecting lines and directional arrows. Now, whatever shapes you have made, they are interconnected, and they are interconnected using some arrows. The arrows depict the flow or in the direction that your process is moving. This allows anyone to view the flowchart and logically follow the process from beginning to end. Obviously, if you have a proper flowchart made for the code that you are writing, then anyone who takes a look at the flowchart can get an overview of what your code is doing. So flowcharts are a very good tool. Yeah, it actually is a tool. So flowcharts are a very good tool to visualize the ultimate program that you have written or piece of software that you have written. Now there are several types of flowchart. We will not discuss it in depth. We just take a look at the names or the types rather. So the first one is swim lane flowchart. Second one is data flow diagrams. Third is influence diagram. Fourth is workflow. And fifth is process flow diagrams. These are some of the major types of flowchart. Now this data flow diagrams, this one you'll be using a lot when you are making some project, and process flow diagrams as well. Now in data flow diagrams, you actually depict how your data is flowing from one part of your uh, project or program or code, whatever, to another part. And data flow diagrams or DFDs are a very essential tool that you'll use in later part of your course. Uses of flowchart: project planning, project or system design, process documentation, audit a process for inefficiencies, mapping computer algorithms, and documenting workflow. So these are few uses of flowchart. Even in your course of study in BTech Computer Science or IT, you'll be going through flowcharts and you'll be using them. In Java. When you study Java, there is a concept called UML, Unified Modeling Language. So these UML diagrams are also very essential. They are also kind of flowchart. And when you make any project, the first step will be to understand the problem, and the second step will be preparing a data flow diagram. This data flow diagram, which I discussed over here, types of flowchart. This data flow diagram gives you an overview about how your entire project will look like, and then you can divide your entire project into chunks and then start off with coding your chunks, because it is not possible to code the entire project at once. So that is how data flow diagrams help you. So that is all for your this video. In the next video, we'll get started with actual C programming. Thank you.